Hi there, Cindy. So we're going to start our little chemistry stuff here. I'm just going to jump right in. This is kind of going to be an intro um, recording here, video, kind of about chapter one, but maybe a bit more generally speaking, kind of philosophy of chemistry, if you will. And again, I haven't yet seen any of the lectures yet from your professor, but I just kind of want to jump in and get started on this. This will be a pretty short one. By the way, by way of intro also, I'm going to try to keep these videos at or less than 15 minutes is going to kind of be my goal. Targeting around 10 or 12 minutes each, and I think that's the right length. Just in terms of, otherwise it gets really kind of, they get kind of boring, and it also forces me to stay a bit more focused on a certain idea or set of concepts. So yeah, I'm going to try to do that. Again, this one I think is going to be shorter, although I probably ought to stop rambling, or maybe that won't be the case. So a couple things about chapter one. This is kind of by way of intro. First, I want to drop back and talk a little about physics just for a second. In physics today, it is well known around the community that there are 4 known forces in the universe. There's only 4, and in fact, there's great lengths to try to unify the theories of these forces and all that, and there's a whole topic there that I won't cover. But I want to tell you what these 4 forces are, because it puts in context what chemistry is, and in particular what it is and what it isn't. So the 4 forces in nature are 2 really small ones, meaning they happen on a really, really small scale. One that happens, show my fingers, one that happens on a really large scale, and another one that's kind of a mixture. So the 2 small forces are known as the strong nuclear force and the weak nuclear force. Both of these are forces that take place inside the nucleus. And the strong one has to do with large-scale nuclear reactions like atomic bombs and things like that, nuclear fusion and fission, and those kind of effects. And the weak nuclear effect has to do with the decay of a neutron. We'll get into a lot of this atom stuff. I think you maybe have already familiarized yourself with some of that already. But again, neutrons are one of the primary particles inside the atom. So the nuclear forces are the strong and the weak nuclear force. Those are very, very strong forces. Well, relatively speaking, you'll see what I mean by relative in a second. The macroscopic one is called gravity. We all know what gravity is. But really, gravity is an incredibly weak force, like unbelievably weak force, which is why it doesn't take it requires a gigantic macroscopic kind of scenario before we can even see its effects. So it's basically planetary or larger. Well, that's not really the case, but large objects like objects that we know in our solar system, like planets and moons and stars and even comets and asteroids and things, but not like atoms or really small things. The last force is probably the one that's most well, I shouldn't say most common, but it's the one that we experience most in our lives. Is called electromagnetism, and there's a history there why it's even called electromagnetism, because for a long time we thought there were 2 different forces, electricity and magnetism, and it turns out in reality those are really the same thing. Magnetism is kind of an odd mirror image of electricity, of the electrical force. And if you think about it logically, there's an awful lot of commonality just even in terms of how we perceive electricity or magnetism. For example, there's positive and negative charges, and the opposite charges attract. This is true for magnets as well as electricity. And similar charges, if they're the same, repel. So if you ever try to push a magnet together, when you get too close, it starts to fight you, and it would much rather repel away. Electricity works exactly the same way. If you have a positive object and a negative object, they attract electrically, and if they're the same, they repel. So again, electromagnetism is the 4th force, and it pertains to a lot of things. I'm going to focus now just immediately on what that means inside the atom. Inside the atom, this boils down to essentially electrons and the positive counterparts, which are called protons. I know you know all this stuff, but I'm kind of simplifying it. So, and now this is the key takeaway of this video, is that this is, for my opinion anyway, chemistry is all about the electrons. Essentially, the patterns and positions of electrons relative to the nucleus, and in particular the positive charges inside the nucleus. So chemistry is it's basically all about electrons. And I mean I can't you'll see I'll be redundant. I'll be saying this over and over again. It's all about the electrons, because it is, and especially when we get in organic chemistry, even more so. But you'll see throughout this entire course that even things like the periodic table. If you look at the periodic table, it essentially is organizations of materials, of elements, according to their electron structure, or the groups of electrons, how their electrons behave. So all of this stuff, bonding, chemical reactions of all sorts, it's all about electrons. And in fact, the book will constantly say that the protons in a chemical reaction are not even affected at all. Basically, if you have an atom of, pick an element, chlorine, and it reacts somehow to form a different compound involving chlorine, the chlorine atom, its protons and its neutrons, are completely unaffected by this chemical reaction. They're exactly the same. The things that change is essentially how the electrons of that chlorine atom are repositioning themselves relative to other elements that are involved in the same reaction. So this theme happens over and over and over again. And so I think it's critical to kind of embed this in your brain, that this is all kind of about the electrons, how they form, and essentially later I'm going to get into, I'll probably even have another intro video like this that talks about chemical reactions philosophically even, and talking about essentially why they happen at all, and you will see that the big actor here is electrons. And of course, the second big actor you'll see is energy. And so and I think this chapter even touches on this. Yeah, in section 1.1 it says, right after it talks about the central theme in chemistry, there's a little section on the importance of energy. And I'll save another video where I kind of maybe try to explain that at a higher level, why energy is so important. But energy is vitally important in the discussion of chemistry, because essentially chemical reactions are all about repositioning the electrons with respect to the elements involved in the reaction, such that the end result is to create a more stable resultant from an energy perspective. It all boils down to energy at some point as well. So maybe I need to say it's all about the electrons, but it's also about the energy result from the combination of elements and their electrons. Okay, that was all I wanted to kind of cover on this one. Chapter 1, as you realize, is a lot about kind of getting ready to study chemistry. So it talks about significant digits and the scientific notation and all that. I'm in this, but I probably will have a couple more intro things before I get to chapter 2. So chapter 2 is really where all the meat starts to happen. But I'm probably going to have a couple more. There's actually one more that I want to do at least. So maybe I'll have one more video to cover odds and ends. Okay, that's it for this. I'm going to end it now.